This topic is Intro to Node.js. Going to talk a little bit about what is Node, why do we use it, why do we use JavaScript, why is it better and or worse than all the other options that are out there. My name's Jameson Pranos. I'm a development manager here at Accusoft. I have a couple of teams that work on web applications in the SaaS group. I still, at least in my mind, I'm a developer and pretend to be a developer and write code every now and then. I'm scheduled for my management lobotomy any week now, but still like to pretend I know what I'm doing. So what is Node.js? First of all, who here in the room has developed or is currently developing for work or for pleasure in Node? Okay, so a lot of experience with it. Node.js is simply the Google Chrome V8 engine for JavaScript implemented as a server-side runtime. So you can run Node or JavaScript applications on your servers, on your machines. And it's got a lot of things that really led to its quick uptake and quick popularity. First of all, the code you're writing is JavaScript. The same JavaScript that everyone uses on their web clients, the same JavaScript that has a very active community discussing best practices and new standards for the language. It is second only to Java in number of questions on Stack Overflow. So those who have come from a little more esoteric languages or languages that are a little long in the tooth and no longer quite as popular, Stack Overflow questions on JavaScript usually have a lot of answers. People who actually contribute to the runtimes, to the engines, people who are actively discussing how to improve the language. All that leads to a very developer-focused community. So usually if there's a problem you're having in Node, there are thousands and thousands of other people having that same issue, upvoting the issues and getting those up to the maintainers and getting those things changed. It's cross-platform. So Java's old thing was, write once, run everywhere. Node is exactly the same thing. The Node runtime works on embedded systems. It works on all standard variants of Linux and Unix and Windows servers and desktops and Mac OS X, as we can attest to. So you can pick up your software, and as long as you're careful not to write anything specific to the file system or structure that you're expecting there, you can pretty much expect it to run anywhere. And that's a huge benefit for portability and not having to rewrite your code and implement new libraries. Speaking of the libraries, there are tons of them. There's lots of libraries available in Node, different modules that allow you to perform lots of different actions, interact with different systems, or anything you need to do. Again, it's a big developer community, so a lot of people are contributing code to it. And there's a very small footprint for running Node. Getting a Node runtime on an embedded device for something like Internet of Things, a web-enabled thermostat for your home or garage door opener or something like that, it's not a heavy system. You can put it on something that's embedded and small and cheap. You can easily run Node on a Raspberry Pi or an Arduino board and do small automation things without having to worry about the bloat from the language. So onto the modules. There's an app for that. There's a module for basically everything that you can consider doing, aside from whatever your value add is. If you want to develop a certain product, all the support is probably there. All the tools you need to build it are there. You just build your logic. So if you need to work with the file system, if you need to stream data, whether that is over a network, over a file system, over some other kind of pipe that's built in, if you need networking and sockets down to the bare bones layers and all the way up to HTTP protocols, SSL layers, that's all built directly into Node with no external libraries. Cryptography, there's a very robust crypto library that's included with Node. There are a few options that are not included, which can be added third-party, but all the basics are there. You can build a solid encryption into your system, encrypt your own data if you're not sending it over SSL natively. Event-driven actions, so anyone who's ever done event-driven programming, that's native in Node. That's just part of how things work, and there's lots of libraries built in that let you leverage that and write better event-driven applications. HTTP and HTTPS servers, no external libraries to introduce. You can have we were playing around with one of the demos earlier and removing some white space and got a HTTP server in about 30 characters of one line of code that was an active HTTP server. And then for what's not included in Node, there's the open source community. So most of you have used, or a lot of you have used Node, so I'm assuming most of those people have used NPM. That is now an acronym which stands for any number of things. If you go to their website, it actually randomly generates words that start with NP and M because it's no longer the Node package manager. only because they support packages for a lot of different places now. But it was originally designed for JavaScript and Node, and it's extremely simple. It does version management, dependency, deep chains of dependencies, and there's over 250,000 open source packages in the NPM repository, as well as the fact that you can take the NPM software and run a local repository. So you can have all of your own code sitting in an NPM repository, and when you tell NPM to pull down a module, if it can't find it on your local repo, it'll go out to the public and find it. So it's pretty transparent. You do a pass-through, and your libraries come first. You can also take a lot of those same libraries and run them directly in the browser, because again, it's JavaScript. So if you pull down a library that does something interesting, a lot of people have used jQuery or underscore or any of those on the client side. All those same libraries can be pulled down via NPM and used on your server-side code. So all that same functionality with combining objects, combining arrays, a lot of those shortcuts we can take straight from the client world and use the exact same code on the server side. So Node, what makes it different from most other systems? And some of these are going to be similar to another system out there. There's lots of single-threaded models out there, but most of what we work in, if we're coming from C# or PHP pre-fork or Java, is going to be a multi-threaded environment that's blocking. Everything in Node, your application executes on a single processing thread. So while behind the scenes the V8 engine is all kinds of complex and C++ multi-threaded goodness, your application runs in a single thread that is non-blocking and works off events that get fired. That means that when you have something that is waiting for file I/O, waiting for a network response, waiting for some controller to return from a physical device that you're connected to, it's not going to hold up processing of the application. You don't have to spin off a new thread to wait for something in order to stop blocking. You simply give the thing that you're making a call to opportunity to respond by giving it a callback or some other mechanisms we'll talk about to do that. But you basically say, I'm going to let the application continue to run, and when you're done, you just come back to the stack and say you're ready to run, and you'll get put at the end of the list and be allowed. But that way we don't have to wait for a return. We can just keep going with our code and let things happen asynchronously. That is probably one of the most useful and important pieces of Node, as well as being the biggest stumbling block to people new to Node when they try to read their code top-down, and it almost never, ever works that way in Node. Your code will never be top-down. So that general idea is to allow lots of different pieces to all operate on one thread without blocking each other. Anyone who's worked with Apache or Nginx or some of those other things, if you had a single thread in any of those systems, it would be basically unusable, because one person making a request, while that file loaded, it would not answer requests from other people. With Node, your server can say, I got a request, I'm doing some I/O, another request came in, grab that event, process that one, and we can have tens of thousands of active events going at any given time. So there's a lot of good reasons to use Node. There's also probably one very, very, very good reason not to use Node. If you're building a CPU-intensive application, and I'm looking at a lot of people in this room who are on our image processing teams and SDK stuff, who do a lot of very, very CPU-heavy stuff. That's a terrible idea in Node, because it is all intended to run in a single thread and not be blocking. So if you're doing something that's going to take 10 seconds of fully focused CPU time that's not waiting, that is 10 seconds where your application is completely deadlocked. So Node is not meant for that. Node is not as performant as other options like C++. It's just not the reasoning. The library, the language, and the whole runtime were built around the idea that you're going to be doing a small bit of processing and then waiting for someone else. That could be waiting for disk I/O, that could be waiting for a person, that could be waiting for a web response. But most of the time you spend is spent not doing anything, which is true for most of our applications and most of our developers. I promised a bad joke.
Said you were programming.
Well, okay, thank you, Jim. So what type of language is JavaScript? For those of us who started programming when procedural was the only way to go, JavaScript is a fully functional, imperative, and I shouldn't use the word functional there, I guess, a fully working imperative and procedural language. You can go top-down. You can have variables that are global in nature. You can change their state. You can read their state. You can have all kinds of stuff that's very much what everyone's been using since the early days of programming. And so this little code snippet over here, this little function, we have a single function that does some sort of synchronous task, and we keep a state. We set the state to processing. We loop through and run this function. We set the state to completed. This is a global variable. The task's length is a global variable of things that get added in. It's a global member of this tasks array. All of this is something that could be basically copy-pasted with some syntax changes to PHP, to C, to COBOL, to Fortran. This is the core of you could write the simplest procedural thing you want and do it in JavaScript with Node. JavaScript is also an object-oriented language, sort of. JavaScript does not natively support default object-oriented processes. It has a prototypal inheritance method, which means you can modify the prototype of anything that you define, which means that after an object is declared, you can go append methods, you can modify and remove methods, you can basically mutate anything you want in JavaScript after it's been declared. We'll get into more of that in a bit, but they do now have, with ES 2015, which is last year's release of the language, the actual class keyword, which is, it desugars to basically this prototype stuff, but it lets you say class, my class equals new class, and pretend that you're playing with classes. What you're really doing is you're creating a function, you're modifying the prototype of that function to say anything that was built from that. So here I define a task runner, I stick a new task in it, and then after it's been defined, the object exists out there, I now modify its prototype to add a new function, and then I can run it. In most languages, this would say, that needed to have been defined up here. You cannot, at runtime, modify how this thing works. JavaScript just happily lets you break all kinds of things, but it allows for some really cool options for extending objects that were written by third-party libraries, and it's basically the crux of how all of those client-side libraries like jQuery and underscore work, is they hijack the native elements in the browser, and they give you control of them. It's also a functional language, sort of. You can write functional code in JavaScript. It is not purely functional in that it will let you mutate state, it will let you use global variables. Again, JavaScript is going to let you do whatever you want. But you can write fully functional code. So functions are a first-class citizen in JavaScript. That means they are treated like any other object. You can pass them around, you can mutate them, you can move them from one function to another. You can take one function and pass it to another library and have it replace its own inner workings with your function. This example here is way too complex for what it does, but we have functions that will double a value, add 5 to that value, and put an x at the end of it. And then we make this function, which takes any number of arguments and composes them as a chain of functions. So f of x of g of y. And we make a new function. So this defines a new function that composes all those together. So anything we pass here now, I'm going to take all 3 of those numbers and process them. It's going to take the number, 3, double the value, 6, add 5, 11, append an x. So the output of this is going to be 11x, 19x, 9x. All of that by taking all these functions, composing them, and passing them as values. So you treat functions no differently than you treat a number or a string or anything else. In fact, you can take a function variable and recast it to a string to see the name of the function. So they're fully first-class functions. If you're using JavaScript in this mode in functional programming, it is on you, though, to verify that you don't mutate state and change the world around your functions. The whole point of functional programming is everything can be modeled as this input into a black box function gives this output. As soon as you change this global variable to increment a counter, you're not functional programming anymore, you're back into the procedural world. This makes very maintainable code, because unit testing becomes very simple with functional code. Checking a chain of what happened and what calls went where becomes very simple. Building trees of your logs becomes very simple with functional code. JavaScript is great at doing this kind of work as long as you have the forethought to stay in that mode and the willingness to do code review and tell people when they mutated state. And finally, I was told to add this slide. JavaScript is a dynamic programming language. So as we mentioned, you can change everything. We don't statically type anything in JavaScript. We do duck typing. So if something is a number, if it looks like a number, then it's a number. If it looks like a string, it's a string. If you can run it, then it's a function, or if you can call it. Everything's interpreted in JavaScript. There's no pre-compilation. Now, the more advanced things get with Chrome and with V8, there's lots of just-in-time compiling that happens, but as far as you as the developer are concerned, it's being interpreted. So everything is fully mutable. You can take things that are built into the language, and you can completely overwrite them. Right here, console log, for those who have used Node, it spits something out. So here's our output, hello world, just like we'd expect. We can then grab that to another function and override it with a new function that figures out the date and prepends it. And now anywhere else through our code, every console log we do, we'll throw a timestamp in front of it. And this is why it's so powerful to be able to mutate things, is doing something like this in a language that's managed and requires you to define everything ahead of time isn't possible with language internals. You'd have to write your own mylogger.log, and then everywhere in your code replace console.log with mylogger.log. This lets us put this little chunk of code as a library in our client-side text, right in line in our HTML page, and now every library that runs, everything in my third-party libraries, everything that I have no access to, all their logs suddenly have timestamps on them. So it's very powerful. It's also very dangerous in that you can completely break third-party libraries by changing dependencies that they were expecting to be there. So it's important to use that well and with great power, etc. Variables in JavaScript. So we have a var keyword which defines a variable. You can assign at compile, or you can assign right then what you're going to set the value to. You can also leave it undefined. When you define a function and pass variables to it, those parameters are scoped into the function. When you assign a value using var inside of a function, you're scoped to that function. But anything outside is global. And then, if you don't use var, no matter where you are, you're using a global variable. So if you just say a equals 7 buried 20 functions deep, you define that globally for the entire scope of your application. Something to be wary of. Always use var. One thing that's different from a lot of other languages is only functions provide scoping. So if you have a for loop or an if block and you define a variable inside of it, it's still scoped to the function that contained it. So you don't have scoping inside of every block element. And then, because all variables are untyped and the scoping can be global without var, you have to be really careful that you're not having side effects, that you don't use similarly named variables without scoping them properly and have side effects that affect other parts of your code. This gets into some of the functional programming stuff where if you're not scoping things correctly, you can accidentally not be functional. And they did add some syntactical stuff that lets you pass things in as part of the scope. Oop, I lost one. So to get into some of that, we'll go through all the different options in this code that I hope everyone can read. So global variable 1 defined at the top is now an official variable name. You can reference it in the code. It is undefined. There's no value to it. And we'll get into the definition of that in a second. Global variable 2 is automatically be instantiated with a value. Then you have a function, which gets function variable 1. So this is scoped to the function. It's not available outside. It defines a var function variable 2. Again, scoped to the function. This if block, because this thing's in a block, this var function variable 3 is still scoped to the whole function. It's not enclosed in that block. There's nothing that keeps it contained there. We can set a new global variable by not using var. This is that whole leakage of variables that you have to worry about when you're doing functional programming. There should always be a var there or you're doing something really weird. And you can take a global variable and modify it inside of a function. So everything is basically, if it's global, it's by reference, not by value. It's not even being passed, so it's obviously by reference. So inside the function, we have access to all 6 values, including one of them which is undefined. And then outside of the function, those function variables are not there. If I tried to reference any of them, I'd throw that error. Reference error, function variable 1 is not defined. So if I try to echo it down here, I'm going to get that error. And that's because undefined and not defined are 2 different things in JavaScript, which makes so much sense. So null, undefined, and not defined. In a lot of languages, in a lot of databases, and a lot of systems, and a lot of diagramming, all those would be the developer couldn't think of a good word and they just picked one at random. They're all the same thing. They all mean there's nothing. Null is a reserved value in JavaScript. You can use the literal null with no quotes around it as a value, and that means there's nothing here. You can also leave something without defining it in the first place, or set it to the literal undefined, like var x equals undefined, to say this value is not defined. I either haven't decided it or I don't know if I should use it yet. But it is a valid variable. I can refer to x after that and do console log x, and I'll get undefined. Not defined, on the other hand, means maybe you typoed the variable name, maybe it's out of scope, but it's actually something that's going to throw an error if you try to use that variable. So there's a big difference between undefined and not defined, and especially when we get into callbacks, and I have some slides that have a lot of that, undefined is used very regularly because we usually refer to our errors as undefined if there's no error thrown by something. And then there's the concept of truth inside of JavaScript. So JavaScript basically works along the lines of truthy and falsy values instead of true and false. False is falsy. Undefined is falsy. Null, zero, empty string, not a number. These are all things that it interprets as false. So if I say if null then something, that will never happen because it's false. If I do if not null, then that will always happen because null is false, not null is true. If true means execute it. Anything other than those 6 values is truthy, which means it'll become true when you cast it in a comparison. So for instance, assume we got back from some function a list of errors. That list of errors is expected to be an array that has all the errors that occurred during processing. If list of errors, I don't have to say if a variable exists list of errors. I can just say if list of errors. If that's an undefined variable, else, I'm successful. I didn't get back a list of errors, it must have been successful. So if list of errors and list of errors dot length. So now it's got to be an array with a length property, and that length is greater than 1 or greater than 0, because if list of errors dot length is 0, 0 is falsy. So then I would get if true and false. So no errors means I can handle them. You'll see this a lot in things that look for elements on the client side. You'll see things like jQuery looking for a bunch of elements on the screen, and then they'll do if that selector dot length do something, instead of saying if that selector dot length is greater than 0, do something. It's a shorthand, but it's kind of a core part of a lot of JavaScript stuff that you have to think of things as far as how they're going to evaluate on true and false, because they get used as comparisons a lot in conditionals. Yes?
So if list of errors is undefined and it's technically linked, wouldn't that be an error?
Thanks for setting that one up, Jerry. So JavaScript does lazy evaluation, which means that with an and, as soon as one thing is false, it doesn't have to keep going. So if this comes back false, it won't even evaluate this. So it'll stop. With an or, on the other hand, as soon as one thing evaluates true, it'll stop evaluating. It only evaluates from left to right as much as it has to in order to decide whether or not it's going to move on. You're welcome, Jerry. So I'm going to start with what I mostly work on, which is web apps in Node. We'll start at the high end and move down into the console apps. But again, we have native support for HTTP and HTTPS. So the single line, require HTTP or require HTTPS, gives you a working model for a web server. There's also lots of libraries out there if you're trying to build a RESTful interface. It's highly recommended never to build something from scratch. Don't reinvent the wheel. There's lots of stuff out there. We use Restify internally at Accusoft for most of our REST APIs. There's lots of others. Express for web apps. So if you're looking for something that's going to be able to add a view layer and a middleware layer and rendering and caching and all that, Express is a framework that has middleware and plugins to do basically anything you'd expect in a first-class web app engine. And so if you're building a full-featured web app and not just an API, it's a really good framework to use. So we're going to look at building a simple web app in Node. And get rid of the Wi-Fi password. Okay. Okay, so here's the code for our very simple, this is the one we removed some white space from and got it down to like 30 characters earlier. But this is a functional web server. There's nothing running in front of it. This isn't like PHP where you have this giant Apache stack in front of it, and then you get to do a nice one-line echo hello world on it, and you're kind of relying on all that code. This is the entirety of the source code for a web server that's actually listening on a port and doing its own routing. And so all we're going to do is include that HTTP library. We're going to create a new server, and every time it gets a request, so we'll talk about the callback structure, well, it's actually taking the action whose parameters are the request and the response, and no matter what I give to this web server, it's going to end the response by responding with hello world. And then it's going to take that whole object and it's going to listen on the specified port. So we have a web server listening on port 8080 that always says hello world. And this is the kind of stuff that we get paid to do. So there it is. That's as good as it gets. That's the end of my development. I told you guys I was a manager. I didn't lie. So we move on to the next check-in, and here we have a little bit more logic. So we've taken that function that was there, and I've shown how with functions being first class, I can now actually define it in the function syntax that you'd probably be used to seeing, and then include it right there. So now at the bottom, I'm just doing my HTTP library. I want to create a server, and the handler for every request is going to be that content server function up there, listen on port 8080. That means I have a running process, and every request that comes in fires that function. It checks to see if I was looking for /index.html. If it is, I'm going to say hello. If it's not, I'm going to throw a 404 error. So index.html, hello, I'm index.html, index.htm because it's 1990, 404 error. Still here, though, we've entirely gone with things that are built into Node. I haven't included any third-party code, packages, anything like that. We're going to go one step farther and actually build what would probably be considered a real web application, something that actually does a static file server. So pulls from the file system and serves up files. And so check out Web 3. So this is our very, very low functionality static web server. It doesn't do any kind of content type headers or a lot of other stuff, but it will look in the file system. So basically, I've added a new public folder up here that has a single index.html file in it, and there's my awesome HTML work. But it looks in that public folder for the URL you requested. It uses the file system module, so at the top I've required FS. That's all that's required to get access to the file system in Node. And it uses that file system module to see if the file that you've requested exists. If it does exist, it's going to go take that file and read it, and it provides a callback. So this is, again, non-blocking. While one request is waiting to read the file, another request can come in and get processed. If we get an error trying to read the file, we throw a 500, because we've already said the file exists. For some reason, we couldn't read it. We're not going to get into more detail. We're just going to assume something went horribly wrong and let the person know that we failed. If there's no error, we'll return the content of the file. So literally, text file, return to user. Binary file, return to user. Doesn't matter. Obviously, we'd have to set a content type header for those who work in the web in order for the browser to understand what's going on, but we can send any data that we retrieve from a file straight to the user this way. Assuming the file doesn't exist at the bottom, we're going to set a status code and throw a 404, just like we did before. So the only new thing here is we're actually coming from an HTML file using the file system. So I can now go in and put as many files as I want, JavaScript, CSS, HTML files, and build up a full website, a full little application, whatever I want to build. And this thing acts as my little terrible version of Apache that doesn't do anything of value, doesn't do any kind of user filtering, but it gets the job done. It serves up files. If we want to get more complex than that, we really want to do something that's going to allow us to not have to write all the plumbing ourselves. So using something like Restify or Express, or even just Connect, which is the framework that Express was originally built off of, lets us avoid having to write all of the port listening and the parsing of URLs and all that. So Express is the framework I'm using here. You'll see I've required it at the top. I'm going to go ahead and throw my first error on purpose so you can't claim it was an accident. If I try to run this thing now, okay, it couldn't find the module Express. But if we look back here in this check-in, all I've had to do was call it. So I have a dependency now in my package that says, when I get this application, if I pull it down from GitHub or I'm I've just written this thing or I pulled it off of source control for my company. When I go to do an npm install and tell this thing, go get all your dependencies, go pull Express out. And so, assuming I haven't screwed anything up, and can type. So npm is going to go do all the heavy lifting and go pull Express and every one of its laundry list of dependencies and all the stuff that it needs to work that we no longer have to write, that's right there in the public open source world. And being Express, it's heavily, heavily used. I mean, there's probably a good 50% of web applications in Node at least are using it because it's just the elephant in the room for frameworks. Now I can actually run it and the app works. Hello from your Express web app. So all the code that was required on our side, aside from the HTML file, which is super impressive, was bring in Express, start a server from Express with no parameters, just the default web server, and then tell that server to use a static route of the public folder. I could also do lots of other things, like telling it to use my own function, certain endpoints, which I'll get into in a second, but then I just tell that server to listen on 8080. And the real important part of what's happening is actually what's happening inside of Express. So inside of Express here, that .listen 8080 and the first call to Express is actually going to that HTTP library that we were just using and doing a create server. But then on the function to handle every request that comes through, instead of having a function right there, it's sending it into Express and saying, I will register handlers and events and callbacks for all the different types of events that can happen in that server. And so this thing can inject itself into the HTTP server and build on those libraries. Again, it's somewhat object-oriented, but not in the literal sense because you can go change those objects. Nothing is really private. And the final one in this tree so here, before all we've done is insert this part here. We've added this code. So we're requiring an operations.js file, which is just our own external library. So rather than using node modules that are built in, or rather than using npm modules that are pulled in as whole modules, we can just include another file. And so that module can export some interface. Whatever it exports is the public interface to this thing. So we're exporting two functions, add and multiply. They'll take any arbitrary comma-separated list of numbers and either add them all together, multiply them all together. Tough stuff. And then what we do is we put a special listener on /demo/:operation, which means I can put any string in there, and that's going to be turned into a variable that I can use to figure out what operation you're trying to do. So I go get that param off the request for the operation. I go check the query string, so question mark numbers equals 1, 2, 3. I then check if my operations here has one defined. So I've defined add and multiply. Nothing else should work. So again, if operations op, that goes back to the truthy and falsy stuff. If there is nothing defined, operations hello is going to return undefined, which evaluates as false, which means this is the same as saying if type of operation op is not equal to undefined, but this is the nice concise way of writing it. So if we try to do a bad operation, we're going to get the following operations are supported, and we'll list out all the good ones. These are the only things we let you do. If you do give me a good one, we're going to split the number on the comma. I'll admit I did not do good error checking here. If you pass malformed data to the numbers, it just blows up. But then we take the function that was defining those operations, and we pass our numbers to it, and then we send the result of that function straight out to the browser. And then right below that, we use public. So Express always goes top down. Whatever order you register your handlers in, that's the order they get checked. So basically, we're going to see if they went to /demo/something, this handler will kick in. Otherwise, everything goes and looks in the public folder and sees if it can find a file after that. Oh, and I've modified our HTML to almost be like something real. So we actually have a form that we can submit to do our math. So, do I have it running? Yes. Okay, so now we support addition and multiplication. So here's add some numbers, and there's the output from our function. All those numbers equal 42. Surprise. And if we multiply numbers together, what do you know? But from our URL here, this is, well, it's not really big, but /demo/multiply. If we have divide, because I have no idea how I would do that, I guess I just go in order, but following operations are supported, add and multiply. So that one function provides a nice, easy access to the web interface of how do I want this thing to work. Of course, it made it unpretty for me by URL encoding, but oh, what did I do? Oh, yes, I did not put, it would help if I put a equal sign there. There we go. So I can put in numbers, it's going to multiply them, it's going to add them. That is the essence of good programming, is being able to add numbers, because that's what we really wanted computers to do for years. So that gives us a very simple Express app that serves up static files, static HTML, and you can see all I'm doing here is going to /demo add, because anyone in the last 20 years can tell you using a form that pushes to get is a great idea. That's always best practice. So we're not posting, we're just doing a get to keep it simple. But there's nothing that says we couldn't do that. We could easily change the method to post, and then in our app code, we would change this to server.post that. It's just kind of awkward to have post return an HTML or return content that we're displaying on the web, so I went with a get. So back to the presentation. Debugging Node applications. So first of all, again, everyone who's worked in Node and worked in JavaScript before, how many people have used an interactive debugger with Node? Many fewer. Not a big surprise there. Yeah, that there is. It is weeks old, man. You should know this by now. So in Node 6.2, which is in early releases right now, and will be in October will become the official LTS for Node. So in October we all get debuggers, because all of our higher ups are going to let us take time out of our sprints to upgrade to Node 6, right? Yes. So first of all, the default way everybody works with debugging in Node is console log, console error. Actually, it's error, not ERR, but that's all right. I'm allowed to type that. This is the age-old echo. I'm going to put, as one of my developers in the room always does, console log Waldo, and then look through my log and figure out where's Waldo to figure out where my error happened. So that is the down and dirty way to try to find errors in your code. Node debug is an interactive tool. It lets you put a single line of code anywhere in your application, just debugger, semicolon, anywhere in your code, and then you can start the debugger up, thanks Mike, and watch any variables that you're interested in the value of. You give them a string value that will evaluate to the name of the variable, and every time it trips across the debugger, it's going to show you the couple lines of code where it was, as well as the value of anything you're watching at that time. So many keyboard shortcuts. There we go. Get back there. Console apps and debugging. Web 6. Okay. So here, I've taken that exact same code we had and I've added a new file, console.js. So we now have a console application, a little easier to work with than a web application for this debugging. But it's actually pulling in that same operations.js we were using. So no different than anything else. We can create libraries, make them reusable. I could go publish my awesome add and multiply functions onto NPM if I wanted, and then you can all check them out and use them in all your production code. We're going to require operations.js. We're going to take things off the argument line, so anyone who's worked in C languages is probably used to the argv, argc stuff. You basically ask the running process, what are the arguments that are coming in? Argument 0 is always node. Argument 1 is always the name of your file, because you type node app.js space all your arguments. So ignore 0 and 1, you start with 2. So what we're expecting here is I'm going to run node console add 1, 2, 3. Node console multiply 4, 7. So I'm going to pull those things in off the command line, and then I'm going to do the same thing. If the operation exists, split it, call the operation, console log it. Otherwise, same errors. So no big surprise here. It's going to work the same. Node console add. So exactly like our web application did. It's going to do the same thing, except for outputting to console. So I could put as many console logs as I want through here, try to track everything that happens. I could put one on every line. the biggest thing is anyone who's worked in a real production code base knows you end up with lots of console logs committed to your code base. Everyone puts in lots of, here I am, why is this happening, all over the code base, and then forgets to get rid of some of them before they check in. So for cleanliness, it's usually a little easier to type 7. I don't know why I made a separate commit to add a single line, but hey, I don't want to type.
Hey, saved you on that typing.
That's right. There's way more to type, get checkout, but that's okay. So we've added a single debugger line, which means every time I come through this operations thing, assuming it does exist, if I fail, I won't throw anything. But if I get in there to actually do the calculation, right before I actually call the operation, I'm going to let the debugger halt, and that will automatically spit out anything I'm watching. So first of all, just before I get into it, there's a variable numbers, which is an array that I got from splitting all the string up by commas. And then I'm also going to look at the variable op, which is what operation I'm trying to perform here. And so if I go in here and just add debug into Node, console, add 1, 2, 3. I guess that would work too. Make sure I did that right. So that's going to start the debugger, and it always breaks on the first line. That gives you the opportunity to start typing in commands. You can. There's a bunch of commands. I've actually included the documentation in the slide, which I'll publish at the end of this. But there's a bunch of commands as far as setting breakpoints on lines, on entry to certain files, on entry to different functions. But one of the easiest ones is to actually tool your code with debugging lines and say, here's where I want to break. And then we said we want to see the value of the op variable and the numbers variable. And then C or continue tells the code, go to the next breakpoint now. So it hit the debugger line. It stopped. It told me op equals add, numbers equals array of 1, 2, and 3. So this is the thing it's about to perform. I tell it to continue again, and there's the output of the application. So if I have a loop, if I add these things, anywhere throughout here, you can go in. Anytime it stops at this prompt, before you hit continue, you can add breakpoint, remove breakpoint, ask for the value of a certain variable. So the debugger is really powerful. I foresee a lot of UIs showing up around it in the future because it is socket-based. It actually runs, you can actually run an interactive session off the server. So you can actually start with -- debug on Node and then run Node debug on your local machine with an IP address and tell it where to point and start running the debugger against your Node code on your production environments. So there's a lot of stuff you can do with the debugger that's coming up in 6.2. Hopefully it makes debugging in Node less brittle, because everyone that starts moving into Node always goes, okay, where's the debugger? Okay, well, you use console log, and you hope you don't have big bugs.
So it has some debugging. So that's what I thought you meant. Yes,
Oh, yeah.
I don't know what it does. It's magic. Wizardry.
Yeah, it probably has its own runtime.
Yeah.
Knowing Visual Studio Code. I'm not that fancy. I like to use Notepad still. I put the little badge on my website, made in Notepad. Best viewed at 800 by 600 in Netscape Communicator. Okay. So back into development in JavaScript. Asynchronous development is the biggest roadblock, the biggest hurdle that people usually have to figure out their way around and kind of wrap their head around, that things do not run top to bottom or, function to function call. Callbacks are the standard development pattern for asynchronous development in Node. Pretty much every standard library you find in Node, everything you npm install, is probably built using callbacks because it's the standard. It's really probably not the cleanest way. I don't think most people tend to like doing it, but every other library is built that way, and if you were to do something different, nobody would understand how to use your library out of the box. By convention, all callbacks usually take an error parameter as their first parameter, and then the response. So it's usually, tell me if I had an error, and then if not, give me more parameters that give me the feedback from my, what I just called. And then more modern style, we have promises. First, is anyone in the room who doesn't work for Accusoft using promises in their Node code? All right, so we do have some. Hey, you work at Accusoft, don't lie. Raising hands. So promises were added to Node Core in version 4. It's a little over a year old now, and they were originally available in a lot of different libraries. So Q was the most popular. Bluebird is probably a slightly nicer library and gives a little more functionality than the standard spec. But they've been available for a long time as third-party libraries. So all of your asynchronous functions actually return an object that expose .then, .catch, that can be chained together. So they're event-driven. They let you just basically say, when this thing resolves or rejects, which is the terminology of promises, when this thing succeeds or fails, then move on with my functionality. And so, a code sample is worth 1,000 words. Oh, I don't know that code yet. Okay, so we'll go into demo. So here is some asynchronous process. This happens to be a function that takes a number of milliseconds as its parameter, and then a callback to call when that number of milliseconds has passed. If you don't pass in a delay, or you pass in something that's not an integer, you'll get an error. So you'll see it does callback, new error. In other words, the first parameter it passes back is the error that you threw. And the successful method, it's callback undefined, comma, the delay. So we give you back the number of milliseconds you said. We say undefined is the error. It didn't fail. Here's your response. And then later on, in our actual function that we're going to use it on, we're going to call execute with callbacks with whatever the delay is. We call that process, and when we inline our function, we say we're going to put a function here, a callback, that expects an error and a response. If we got an error, log the error. Otherwise, log that we processed for that amount of time. So it's pretty simple. It's about as small as you can get in a. And so I'll call it with no value. I'll get an error, invalid delay. I did not provide a time. No surprise. 2,000 processing. That was a lot of work. Process for 2,000 milliseconds. So what we're
Sat there processing, like in a loop or something?
no set timeout. Come on. It's asynchronous, Jared.
Oh.
Non-blocking. Come on. Don't ask silly questions. I just covered this. So it's fairly simple. It's pretty easy to follow. But the hard part is, as you get more complex, it becomes more and more difficult to track this sort of nested callback. And so promises, Web 9. So the functionality is going to be exactly the same. Before I get to the code, everything works exactly the same. The difference is now I've changed this thing to return a promise at the beginning, and it wraps the whole thing in a function that has resolve and reject as its two functions, so it's two callbacks. So either reject with a new error or I resolve with the delay. So now I'm making a differentiation between successful or unsuccessful with a naming scheme instead of first parameter versus undefined, comma, second parameter. It's a little cleaner to read. It's easier to see reject new error means I'm failing. The number of times I've accidentally meant to resolve something in a callback, but accidentally did, callback, congratulations, and it says you've thrown a new error called congratulations. So having to put that undefined in there, it's convention, but it's kind of messy. And then when you call it, you actually call the process, and then you extend on it with .then. So that promise that comes back has a .then, which says .then registers a callback that as soon as this thing resolves, I will execute. And if I reject, I automatically chain down and get to my .catch, which is attached to the reject function. And so if I succeed, console log. If I fail, error. You can kind of see, looking at these two, the code is almost same length. There's really not a whole lot of difference in the simplest case. So we go to something a little more complex here. Back into my super complicated math, we have a function called add 5, a function multiply by 3, and a function divide 10 by number that checks for divide by 0 errors because we're being careful programmers. So when we process the value, this is where it gets the Christmas tree of doom effect. The more you do this, the more it moves to the right, and you get to scroll horizontally. So we're going to add 5, and we're going to get back, or we're going to give it a value, and our callback's going to check for an error. If there's an error, we'll call back with our error. Then if there's not an error, we multiply by 3, and we keep moving over. Try to do this if there's an error, if there's not an error. Try to do this if there's an error, not an error. And we end up with, at the end, callback undefined result. So we have one success case and 1, 2, 3 cases where we put callback error if something went wrong. Getting into production systems, you get things that are 10, 20, 30, 40 chains deep on the callbacks. Obviously, you pull some of them out into functions and clean it up a little bit, but you still end up with a whole lot of callback error that gets propagated up 20 functions to make it work. At the end, it looks the same as the first one did, which was if there's an error, else return the message. And so go back here. So again, we had node demo 0. So 0 plus 5 times 3 divided, or 10 divided by that, 0.666. If I do -5, I get a divide by 0 error because I try to do 10 divided by 0. So the execution is not exciting. The code is really long for what it does. If I check out Web 11, I've now written that same code. So the top parts look basically the same, except I'm returning promise.resolve. And in the case of this one, I'm actually doing the real promise with reject.resolve. The top two just always resolve. But I built promises. The code doesn't look very different at the implementation. But when I call them, I went from that Christmas tree of doom with 20-something lines of code to that. So I basically say add 5, then multiply by 3, then divide by the number. And I return that thing. I don't even have to catch the error, because by returning the promise back, at the actual level where I call it, I say, take the final result of this thing and log it, and if it throws an error, log the error. So I'm able to take that whole page of code and reduce it to this, and make it so that when a new developer joins my team and looks at my code, they go, okay, what do we do here anyway? We add 5, then we multiply by 3, then we divide 10 by the number. I can follow that. And it's very simple. It's easy to go figure out where your problems are. It's very simple to do something like then something like that, and just grab a value from the middle of the processing and see what's happening. So there's a lot of benefits to using promises, especially when we get into more complex systems. And that's the end, folks.